So we are moving into neutralization, which involves acids and bases and salts. And make sure your phone is in your bag. Thank you. Acids, bases, and salts. And so you need to recognize all of them. All right, if you can't recognize an acid and you can't recognize a base and you can't recognize a salt, you're going to have trouble recognizing neutralization when you come across it. So acids, by definition, are substances that dissociate. Are you familiar with the term dissociate? Or is that a word we should define? Shall we define dissociate? Okay, dissociate means to split apart. Have you guys heard the term associate? So if you associate with someone, you come together and you meet with them, yes? So if you dissociate, it means it's coming apart. Okay, so they dissociate when you put them in water. And one of the ions that you get is H+. There's another word in here that I want to define for you because many people get confused by this. It says they dissociate in water to yield. Now, this is not this kind of yield. Oh, that's not very good. Not the traffic signal kind of sign kind of yield. To yield means to produce. Yield means produce. And not produce. Not Brussels sprouts. Produce. Okay, so acids dissociate, they split apart, and they produce H+. So let's take a look at what this looks like in an example. Hydrogen chloride, HCl, starts out on its own. When it's a pure substance, it is gaseous. It is a small molecule, so it is gaseous. So this is pure HCl. Now let's drop it into the water. When we drop it into the water, what do you notice about those bonds? They're gone, right? They split apart, and now you have freely floating ions. Can you think of another type of substance that dissociates when you put it into water? You guys know. You do. Any kind of substance. No? Okay, we'll come across it. That's okay. We'll get there. All right, so it doesn't matter what the acid is. And you can recognize that you have an acid because the acid formula contains an H, right? That tells you you have an acid. And the way we write this dissociation equation is we write HCl together as a gas, and then we have the ions, H+, which is now dissolved in water, aqueous, and Cl-, aqueous. So the HCl splits into dissolved ions. And you can do that with any acid formula. So if you have HBrO3, it splits up into H+ and BrO3-. Okay, and this is despite the fact that technically acids are molecular compounds. Technically, those are covalent bonds. They still dissociate in water to form ions. And it's because hydrogen is weird, okay? Hydrogen, although it is a non-metal, it behaves kind of like a metal sometimes, okay? And don't worry about the ins and outs of that. Just be like, okay, acids split apart and they form ions. So don't think about it too hard. We will talk more about it if you take Chemistry 12 next year. You will learn a lot more about that, but for this year, that's all you're going to get, okay? How would you recognize a base? OH. And did anyone have any questions before we move on from that? We're good? Okay. So bases have OH, and they also dissociate. Tell your partner what the word dissociate means. They split apart in water, and you get OH ions. So let's take a look at what that looks like over here. Here we have an OH minus ion, and here we have an Na plus ion. What is this little structure here? That is a crystal lattice, and it's made of alternating positive and negative ions. So what happens when we put it into water? The ions split apart, and you end up with freely floating OH minus, OH minus, and Na plus ions. So we can show it with the little picture. We can show it using the chemical formula here, where we've just drawn the ions as their little formulas. Okay, they're free to move wherever they want to. All right? Bases are ionic compounds. They're just specifically ionic compounds that contain hydroxide. So if we want to write the dissociation equations, let's zoom in on that. You'll notice that when we have one Na, we end up with one Na. When we have one OH, we end up with one OH. But when we have a different compound that has two OHs, do those two OHs stay together? Or do they come apart? They come apart. So these are two separate OHs. So all you do is you take your solid compound, you write it together, it has no charge. When they dissociate, they split apart into ions that have charges, and you have to make sure you have the right number of each. So those are acids, these are bases. And what was the third type of thing we're going to look at? Salts. Do you guys know what a salt is? It's where you beat someone up, right? Yeah, I know. Okay. A salt. Okay. Anyway, we're talking about a space salt. Salts are simply ionic compounds. All ionic compounds that don't contain OH. So all ionic compounds that are not bases that do not have OH minus. So if you have OH minus, it's a base. If you have an ionic compound, but one of the ions is not OH, it's just a salt. So what's a salt? It's just an ionic compound, okay? And here's our most famous ionic compound of all, NaCl. So this is NaCl solid. What state does it become when we dissolve it in water? NaCl aqueous. And what happens, how would we describe what happens to the salt when we dissolve it in water? We would say that the salt dissociates, okay? And you can write the dissociation equation just like the previous ones, where you start with it together as the solid, and then you have them apart as aqueous ions. That is our dissociation equation. So what you're going to do is you're going to take a moment now and you're going to classify each of the following as acids, bases, or salts. And then you're going to write the dissociation equation for each of these substances when they dissolve in water. By the way, polyatomic ions don't split apart, they just stay intact. So OH stays as OH. CO3 stays as CO3. Okay, don't try and split up NO3 into N's and O's. It's just NO3. Okay, so give those ones a go. So that's on page 76.
Can I go to the washroom?
Yeah, for sure. All good? Yeah. Okay, cool. Because you have yeah. In bed. In bed. In bed. Bag. You know bag? Oh, okay. Oh, right.
I thought it said OH.
Oh, yeah. Oh, yeah. Yeah, yeah.
Oh,
Yeah, you were the yes.
oh yeah.
No. Which is an anion to positive ion and negative ion. So that's not. It has that COO. So in order to get acid, it has to be COOH. Yeah, that's how the H. COOH. Yeah. When you're done one, please jump number two. Okay? Yeah. Oh, that's a good question. I'm going to go over that. So I've had a question, and it is a really good question. So I'm going to go over it for all of us. Okay? And the question is, why do diatomic elements not apply when we're doing a dissociation? Okay? So we end up getting H plus and we end up getting Br minus. Now, if I have Br and it is neutral, okay, it is in group 7. So its outer shell contains 1, 2, 3, 4, 5, 6, 7 electrons. It's in group 17, okay? Is that stable? No. It wants to have a full shell. So what it will do is it will pair up with another bromine to fill its shell. Yes? Whereas what happens is with HBr, we have the H, which has 1 electron, and the Br, which has its 7 electrons, 1, 2, 3, 4, 5, 6, 7. When it splits apart, the hydrogen leaves without an electron, so it ends up having a positive charge, and the bromine leaves with that extra electron from the hydrogen. So because it has that extra electron that gives it that negative charge, its shell is full and it is stable. So when you have Br minus, it's already stable. When you have Br neutral, it's not stable unless it has a little partner to fill its shell. Does that make sense? Okay, so when we have ions, ions don't follow the diatomic rule. Okay, ions are not diatomic unless it's Hg2, which is on your list of polyatomic ions. Okay? I'm sorry, I have to do this. This is like pickling salt. What do I have here? A salt and battery. Sorry, I had to do it. It was just lying there. Oh. Oh, assault and battery, it's a criminal charge. So, like if you assault someone, you're beating them up. If it's battery, I don't know how battery is different, but like it's like you're battering on someone, you're beating them up. It's a felony. Yeah, it's a bad crime. Anywho, now that I've told my bad joke, could we call that a mom joke since I'm not a dad? All right. We are going to move on to page 77 and learn how to do acids and bases neutralization reactions. So there is a video here, so if you miss anything that I say, you can watch somebody else do this, but we're going to do it together. We have sulfuric acid. If we have an ic acid, of course. If we have an ic acid, who is the ion? Something icky. I ate something icky. So that would be sulfate. And so sulfate is SO4 2-. When it is an acid, what ion pairs up with SO4 2-? In order to be an acid, what is the ion that you need? Hydrogen. So we're going to put H plus together with SO4 2-. So what is the formula for sulfuric acid? Okay, so we have H2SO4. It is completely neutralized by aluminum hydroxide. Aluminum is Al3+, hydroxide is OH-. What is the correct formula for aluminum hydroxide? Al bracket OH3. Neutralization reactions work just like double replacements in that you write your ions. We have H plus and we have SO4 2-. We have Al3+ and we have OH-. What are we going to combine? We're going to combine our outside ions. Yes? And what's the other thing we're going to combine? Our inside ions. Do we go forward or backward for the inside ions? Backward. So we go AlSO4. So those are my inside ions. So when I do my outside ions, H and OH, what do I get? I get H2O. I'm actually going to leave it as HOH for now because I'm going to balance hydroxide as a group. Okay? Plus inside ions. What do I get when I put Al3+ together with SO4 2-? Al2, SO4 3. Okay? And now to balance it, you can go through and make your little chart just like you would for other things. You could have your H, your OH, your Al, and your SO4. But I'm going to let you in on a little secret. There's two ways of going about this. You can balance the ions in the most complicated compound first. Who is the most complicated compound? Al2, SO4, 3. So we're going to put a 2 in front of the Al, and we're going to put a 3 in front of the compound with the SO4. So far, so good? Now, how many hydrogens does that give us? We have 6 hydrogens. How many hydroxides does that give us? 6 hydroxides. How many waters will that make? If I take an H, one H, and one OH, how many waters do I get? 1 water. If I take 2 H's and 2 OH's, how many waters do I get? 2 waters. Don't write this part down. It's going to get in the way of the carbonic acid. But if I take 6 hydrogens and 6 hydroxides, how many waters do I get? 6. So another way of balancing these is just to say I need to make my hydrogens and my hydroxides and my waters all the same number. They all need to equal out. Okay, but it doesn't matter how you do it. If you want to use the chart, that's great. Balance the most complicated thing first, that's great. Just balance your hydrogens and hydroxides and waters. That's great. They will all work. Okay, carbonic acid. What kind of ion makes an ic acid? That is an 8 ion, so we are looking for the carbon 8 ion, which is CO3. What is its charge? 2 minus. Who gets paired off with carbonate if we have carbonic acid? H plus. The acid tells us that we need to have an H plus. So what is the correct formula when we put H plus together with CO3 2 minus? H2CO3. I now have sodium hydroxide. Sodium is Na plus, hydroxide is OH minus. All right, so we now have NaOH. How do you know that this is a neutralization reaction? What do you see that allows you to know it from the formulas? You see hydrogen and you see hydroxide. That tells you that it is neutralization. Okay, that hydrogen and that hydroxide tell you that it is neutralization. How do you predict the products of a neutralization reaction? You combine what? The outside ions and the inside ions, just like for double replacement. Who are the ions in H2CO3? You guys are killing me. H2CO3, who are the ions? H. And CO3, what's the charge of CO3? Minus? 2 minus. What is the ion here? Na plus. And how about here? OH minus. So we are going to combine H with OH, and then we're going to go backwards, combine the Na plus with the CO3 2 minus. What do you get as your products? You get H, OH, and you get, what's the correct formula for Na with CO3 2 minus? Na2CO3. Okay, is this a balanced reaction? No. So what you're going to do is you're going to look to your salt and you're going to say, what do I need to balance from my salt? Sodium. So let's put a 2 here to balance the sodium. And once I've balanced whatever is in the salt, I can just say I need the same number of hydrogen and hydroxide and water. How many hydrogen here? 2. How many hydroxide here? How many? 2. So how many water do I need? 2. Okay? Let's try this one, predicting the states. Now, first of all, these guys at our start are going to be aqueous and aqueous. Do you guys think you could predict the products of this reaction? Try it. Well, this is a terrible example. Your ClO4 isn't on your table in your chart of solubilities, but that's okay. We'll come back to it later. I'm going to change this. Change example. Okay. ClO4 is not on your solubility table, but perchlorate is soluble with just about everything. Okay? I'm going to let you know that ClO4 minus soluble with everything. It's not on your chart, but I'll let you know it's everything. There we go. So what would your states be for your products? Water would be, what is HOH? And what is its state? Is water aqueous dissolved in water? Is water dissolved in water? It's a liquid. So this qualifies as your new substance. You have had a rearrangement. You used to have H plus floating around separately, OH minus floating around separately, and now you have O bonded to H, bonded to H. That is our new substance. So this is not no reaction. It is a reaction because we have produced water, which is a new arrangement of atoms. Therefore, a reaction has occurred. So you can, for double replacement, if you get a solid, a reaction has occurred. For neutralization, if you get water, a reaction has occurred. Is good? Okay. And that means because ClO4 is soluble with everything, barium chlorate would be what state? Aqueous. And is our reaction balanced? Not yet. What do we need in front of the HClO4? 2. And do we need a 2 anywhere else? In front of? Huh? If you put a 2 here, now you're just getting further from balance. Where do we need the other 2? HOH. Okay? So your homework is going to be to do page 78. And we have 10 minutes left, so don't put everything away and be like, okay, I'm done. Woo. Finish. Also finish 73, 74, and 76. There you go, 4 pages, 73, 74, 76, 78. But you should have done a lot of that already, so it's not as much as it was. Why is your phone not in your bag? Oh, they're like for and quite frankly, my school today because I was marking things up. I'm very sorry, nobody's getting an award from me. Although some of you might deserve an award from me, I did not get my awards in on time, so I'm like, well, there we are. I know. I'm very sorry. No, I don't go to any ceremonies. I hate ceremonies. They like I barely made it to my home, and that was because I was in graduate college and I didn't find one birthday. Although it was open simple reverse, so a lot of people were like, oh, yes, it was water. Right. So it wasn't quite nice, it was probably a five. Was this for you? This was high school. 9. Yes, it was senior high school, so it was just grades 11, 12, and 3. Back in the day, it was nice. There were like so many sections in every course, right? Like you could I'm sure you would always get the course if you wanted because like there were like icons everywhere. Yeah. Plus there weren't the weird people right? Yeah. It was crazy. It was lovely. And we didn't have Balfours. Basically, the teacher would just dismiss you have to be there on time, and your teacher will dismiss you. They were done, which was usually when the bell would have gone. But I would finish my English work early, and I was with the senile out of your course. Yes, it's possible not learning anything wrong. I'm like, I'm going to university and learn how to write command name, like multiple choice tests for me. Okay, right, but this was an assessment, not someone who was thinking right? That was a skill. I was like, oh, that I really needed to develop. So anyway, there was, and I also missed a student teacher who really, so like I was like, moved to this. So I've seen but I need to get out of here. So you want there and it's you want volunteers and then it's just anybody that wants so basically they just sign all the students that you've got. So there was me and volunteers in mobilization. And there was
Insulation is adaptations. Everybody else. We just write this equation to see if it applies. Yeah.
So first one.
So
So
it's just gas.
I break, like my grammar is good and I break up her. Like I can really learn much about it. But really good lists and trends. Not all the way this. So that was good. And my chemistry teacher, I really see how that was really awesome. I always learned stuff from my like teaching when I first started. No, we're just like research science. And then I took a lot of money for suicide. And it was like, don't invite us. Like, if there's a lot of things, just sometimes you don't need it. And a lot of the time, you're just like, I don't think this year, I don't even know psychology is yeah. And now you're here. And now I'm doing psychology every year and I'm doing about 6 or 8 months. So I don't have that interest in this other thing. But I was more like life stories. So how people like go on their paths, like it's normal. What? I think it's only policy. That looks better than well, I can see, and now you gaslight.
Honestly, reaching out. If I got lost, true, you could just completely see my
I don't know, but that's what I can.
Gotta figure out where to put it. Oh, I remember what I did. But it was because I was writing this in. There's no correct answer. Choose the answer with the correct power button. No. Minnie, do you think I would ever give you the hardest version? Do you think I could live with myself? There you go. You want to work? Yeah. Yes, go for it. That's good. Thank you. Pardon me?
That an means anti-official.
Ion means anything with a charge, positive or negative.
Like,
Oh,
am I doing right?
oh yeah. Oh yeah.
okay.
Yeah. You're good. Yes. Sorry, I misunderstood.
Let's go.
Yeah. I don't love your like this big bug, I don't know. Are you talking about it?
Nothing here, no, it's like
Series and parallel, little series and parallel. All the time, all the time. My friend. Convert it into x squared plus y squared equal r total one. Stretch it over to compress it. Yeah. If you wanna, we can compress it over to one. Yeah, right, you would go. I'll stretch it. Yeah, I'll stretch it. Bigger. It's just like above the denominator. If it's at the list, it's already more above. I mean, no. Sorry. Okay, so it's a list, right? It's a transformation from so. So it's only about the same. So. The original thing was
If you want to make the one of all the same type. By factor, I was gonna say something. My favorite. Yeah, I just maybe five. No, what I'm going to do my stuff is wait, what? Can I have imagine? Well, you're a soldier. You're a soldier. I would never talk about my community. There's so much plus y squared is if it's x squared plus y squared equals 1 or radius squared. And if it's from like one you know how you're the way I saw it, on mine, nothing. And a little like plus one. Okay, these two, right? These two, I was walking from second, maybe the second, you guys are parallel? And then so it's you're not gonna believe them. I'm ready. All I got I actually accept that. Just want me. I did. You have to.
had to say exactly.
I created.
Oh, fly over here.
I don't know why, but so I want to do too. I too, just.
I got a crazy story. You can hear it. No.
I think I do it. You can do I. The reason is no. Your actions will. So you kind of just like.
Really good.
And then I saw it right here. You know, like right watch me see what this is. Really, my brother said that is just every day. I'm not inventing what's looking at me. I'll just be doing it.
Yeah. I know what happened. I'm gonna go.
Wait, have I? It's like you give me a little sample, you might also they give me a little sample. But then, when I would, if I write on two both sides, I want to see one full, so there's just one, take away, I would. That's how I feel. I'm serious, I'm getting 30 as fast as
Oh my god.
Running is not bad, I just roll for its name. Well, it's not hard to be creative on the worst guy, right? use this one. Figure it out and what's the- No, this week. Yes, that's nice. Yes, I'll, yes, I'll show you.
I did not say that. Or they said that.
Yeah, this is your job.
I don't know. That's what she knows what that is.
What am I gonna do? Wait,
I'm looking, I'm not.
This is not the-
I don't.
Yes.
Obviously, apparently there's a new snap that I'm. It's like.
Even. That part was so funny.
It's just I haven't
He's so much fun. Yeah.
the good parts. Just like really.
You know what he said? I wasn't on his so we were talking about yeah, one minus two.
Oh,
He said it was my last name. 1 minus 2 yeah. Oh, in my life.
Are you actually?
Okay, but I don't know.
Did you actually solve me? You don't need to solve it now.
Like, I want to, like, it's part of my fingers. He does it every year.
Just some 2 words.
You did it through third. What number were you calling with it? No, I'm still dealing with physics.
They're gonna mark you. Yeah.
Skip, you skip.
So like, okay, so.
Check there, she's not there. It's lunch, so I'm going to.
Minus. I keep looking at my days.
Okay, so,
That's one of the.
yeah,
Oh.
remember, this is one.
Okay. And then there's another one. Wait, let me do it. Let me try.
Yeah.
Okay, so, minus.
It's the exact same thing, just you change the eyes, that's how it goes.
Plus minus.
Yes.
Oh, this is also plus minus. Oh, minus.
I think how it's work.
We went to the same thing.
Same thing, yeah.
One equals 2.
Yeah.
Plus.
Okay.
Okay. Now, wait. Let me put. Okay. So 1, 2, 3, 1, 2. Also 2 is in column. Okay. So then I1 equals 2. 1 minus I2.
Oh, you're doing it that way.
Yeah. And then I3 equals to 1 minus what the hell? Okay. Wait, so I1 equals I3.
Nope, that's not an answer. I tried. This is not an answer.
Okay, then let's plug it in here.
Yeah, so what you do, since that isn't an answer, right? I use this as my base formula. I want to equal to I2 bigger than I2. From here, what I do is, I need to get rid of this I2.
Why?
Because in the answers, I1 equals either 1 take away I3, I3 plus 1. Like I3 is not moving, you know. Okay? That's why we have to.
Well, I2 either equals to 1 minus I1 or 1 minus I3.
Yeah, you can do it that way.
And then what do you do then?
So I chose to put this one into here.
Colin, 1 minus I1.
Yeah.
Okay.
Technically this. So I want this equal to
1 minus I1.
1 minus I1, right?
Yeah.
This will then equal to
So that's 2 I1.
2 I1. But I switched from this I1.
That's what the hell? Oh, and then the other one is I1 1 minus 2 I3. What the fuck?
Is that an answer?
Oh my god.
I was thinking.
Right.
Yes.
It should be. I think I did something. I think it's either written wrong or something, but if you get it wrong, that's fine.
But I1 should be equal to I3.
In theory, that's how it works. But
Yeah, sometimes if you don't have the line coding, you cannot spell it. You know my dad, like, yeah.
I mean,
You're like, what?
Yeah, that's I'll say that. I think oh shit.
You're so stupid.
Oh no, I want
So mad.
I want
Oh, and I'm like, that's the one thing
Yeah, no, that would be. See what I remember that. Can I just like.
Everything's about you. 1 feet.
I wish I would.
You're the right one.
I need. Oh.
I know. You're up right there. Where are all the ladies? You're at one. Please keep the money. I walk you. Oh. Oh my God. I don't just remember where you are. Wait, Ryan is okay. Oh wait, no, I'm looking at so bad. What are you doing?
Since these two are small, you've always. I know you're playing. You said it was. No, listen. No, because I just think the sound from that. I said I was joking. You see what I was shooting?
Oh, okay. So, before picking that other one. I don't mind you talking about
Not again, bro. Not again. Not again. You're gonna hit something good.
it's friendly, okay? I totally.
I want you to. You want some? You want Thank you. No, I thought I was doing that. Because that's it. What did I say?
I gave it to Nathan. Yeah.
Over. You'll be doing over two bites. You get I don't want my so I'm like race no that is working. No, here, I'm going, you know, I like my teachers. So the 100 that's it. I was trying to bring that out of the last night. How would the second?
You want to know?
No, I clutched up, but I it's out of market. He's right. I don't, I have to feel like you need to. I don't understand. Oh, exactly. Is that really bad?
Down there.
I do right now.
Yeah, he's that lot of crowd.
Guess what? The camera behind this article 5 seconds later.
Sorry, I can smell it. Oh, wow. You still sound I told him no.
And it's just cool. I'm glad they were kind of really are you?
I do. I was not and someone else, like, and they want to go pee. I will get it out, right? I love it. I did see that in Korea. And they fell. I can't breathe. No. And then I first so I will come out of that.
This is like you straight up.
I don't think so. I agree. But other why do you think that? I don't know. I just really feel obviously it's gonna ask
Wait, that blackmail was not.
Well, I should have.
I'm good.
But see, it's funny, right?
I know, I know.
You know, since I started until now, I went there.
So the other one's sort of- It's like, yeah, I like it.
I woke up, I had to stare at my wall. I thought I woke up and after that, I don't know.
I remember when like was
Maybe the movie is hard.
That's mine. Thank you.
I know.
what? Yeah, this is.
Oh, link up, link up. Somebody.
Slowly, how about I'm like, hey, I'm full out.
Did you know that? I don't really
All the notes, I was doing the science problem playing. I did not say that. I got it.
Yes, he covered. I told him.
What do you do?
Oh, this is true.
Yeah.
Oh! I just
When he says wow, he's saying like,
Are you right? So that's me. I still well.
oh, what do you want it? I don't have to. Hey, yes. Right, another one. That's nothing.
Yes,
Yeah, and I got like say it's it's like
Hi. Yes. No, I'm not here after school. Yes. Hmm?
I had a road test yesterday, so I couldn't write.
You could have let me know ahead of
I
time.
know, but like I didn't want to fail something. I was kind of embarrassed.
Okay, that makes me unhappy. And why were you away yesterday?
I was absent.
Yes, I know you were absent. Why?
I couldn't wake up for it.
Okay, do you know I had 7 people in this class miss the test?
I'm really sorry.
And I don't know where I'm going to put you all back in there. Like, there's no room. I'll pick one up. So I have to say to everyone who wrote the test last day, thank you, thank you, thank you. Thank you. You're all kinds of awesome. And you talked to me ahead of time, so you're okay.
I said it in that one. No, that's where it's at. Yeah. You don't know. No, it's not, I mean, like,
And you're writing now? What's happening? Okay.
I don't. Well, I got 50 right now. Yeah. Is that what
Yes. And you're just gonna sit here and do it?
Yeah.
Good. Perfect. Okay. Okay, how are we feeling about oxidation numbers? Good? How are we feeling about oxidizing agents and reducing agents?
Yeah,
Well, hopefully you'll pick it up along the way because how many people actually did watch the video? Yeah. How many people watched it? I got 1, 2, 3. Okay, so you guys are on your own because that was part of yesterday's homework. It was like a 10-minute video. What was it? Like 11 minutes? Yeah? Yeah. It wasn't a lot. Okay, so I'm not going to teach it because Tyler does a great job. All right, electrochemistry. Where are we at here? There we are. Good stuff. Okay, oxidizing agents and reducing agents. You're on your own for that. Here we have simple half reactions. This is on page 10. And I know that cut day is Friday, but I will be teaching. So if you are away, you will miss stuff. So what can I say? It's your choice. We make choices in our lives. Okay, simple half reactions. Redox reactions can be written in a special way. They can be split into 2 half reactions. One half reaction is the oxidation, one is the reduction. We already knew all that, yes? Okay, good. In the oxidation half reaction, are the electrons reactants or are they products? Oxidation, the electrons are products. They come out. So when you have oxidation, you can say, oh, look, there went the electron. And when you have reduction, those electrons are being gained. They are on the left-hand side. You can never have half reactions in isolation from each other in nature, because if one species is giving electrons, the other one has to be there to take them. However, it is super useful on paper to be able to write half reactions on their own. So please identify each of these 3 things here as either oxidation or reduction. Write that down. You can just write red for reduction and ox for oxidation. Okay, what did we get? Oxidation, reduction, and oxidation. Okay. So if the electrons are in the products, they are lost. Oh, look at that. An O. Leo, the lion says gur. Okay. And if they're in the reactants, oh, look, we have an RE in there, gur. So if the electrons are in the reactants, they are gained. All right, for now, we're just going to identify and write the half reactions for some simple redox reactions. So to write the two half reactions given an overall redox reaction, this is actually a reaction that I often have going in the fume hood because copper 2+ ion is toxic to the fish. Yes, so I don't want to be putting copper 2+, which is blue, down the drain. So what I want to do is I want you to think about it. Do I want to oxidize the copper or do I want to reduce it to make it into metal instead, the solid metal? Think about that for a minute. I want to take the copper 2+ and I want to make it into copper metal. Is that oxidation or reduction? Copper 2+ to copper solid, oxidation or reduction? Reduction, because it's going from copper 2 to copper. What's the charge of solid copper? 0. Any element in its elemental state, not part of a compound, not just like half of a compound dissolved in water, is always 0. Oxidation number of any element in its elemental state is 0. So let's write in our oxidation numbers. Here, where did I put my little pen? Uh-oh. Oh, this could be bad. Oh, there it is. Okay. So what is the oxidation number of aluminum here? 0. What is the oxidation number of copper here? 2+. How about aluminum? Over on the left-hand side, that is, or sorry, on the right-hand side, that is 3+. And copper solid, what is its oxidation number? 0. So one of the things you might be asked to do is you might be asked to identify what is happening to the aluminum. Is the aluminum being oxidized or reduced? The oxidation number got bigger, yes? It went from 0 to +3. Therefore, Al is being oxidized. Copper is going from a 2+ oxidation number to a 0. So the oxidation number, I guess I could just call it the ON, got smaller. Therefore, copper is being oxidized or reduced? Reduced. And I should actually write that Cu2+ is being reduced because that's what it is in this compound here. And if you had watched the video, I could ask you whether the copper 2+ is the oxidization agent or the oxidizing agent or the reducing agent, but you'll just have to figure that out on your own. So Cu2 plus is the blank agent, and Al is the blank agent. You're going to fill that in after you have watched the video. Okay? So, when we want to balance an equation, or actually, no, that's okay. We're good. Yeah. So if we want to separate the two half reactions, it helps to split apart the aqueous substances. So you get all the ions and you get your complete ionic equation. Then you cancel out your spectators, so you get the net ionic equation. And then you can separate it into two half reactions. So we have aluminum going to aluminum 3+, and we have copper 2+ going to copper solid. So basically you're just trying to get rid of any spectator ions in there in order to write the two half reactions, because spectator ions have no place in half reactions. So we have 2Al solid going to 2Al3+, but more simply, we could just write it as Al goes to Al3+. Yes, we can get rid of our coefficients. Cu2+ goes to Cu. All right. Where should we put our electrons in the top reaction, the top half reaction, this one right here? Where do electrons go to make that balanced? Do they go on the reactants or the products? In the products. How many electrons in the products? How many? Okay, let's think about this. We need to balance both atoms and charge. Right now, what is the overall charge on the left-hand side? 0. What's the overall charge on the right-hand side if I have one electron? I have 3+, and I have -1. That gives me 2+. Are we balanced in terms of charge? No. So that can't be our final answer. What should we have? We should have 3 electrons, which gives us -3, which gives us 0. Now we are balanced in terms of charge. Okay. Cu2+ goes to Cu. Which side do we need to add electrons to? To the reactants. And normally we would put them after, but I'm having trouble fitting them in, so I'm going to put them there. How many electrons should we add? 2, because that's going to balance our charge. So now you have 2 half reactions. So there are 2 ways to look at this. You can say, I know that this is oxidation because the electrons are coming out. Yes? Or you can say, I know it is oxidation because the oxidation number got bigger. This one, you can say my oxidation number got smaller, so it was reduction. Or you can say my electrons went in, so that was reduction. I'm gaining electrons. Okay, this is just explaining what we just did. So the overall charge on each side must be balanced. In those cases that we just did, it has to be 0, but let's say we had a half reaction that looked like this one. It doesn't have to equal 0. It could equal, for example, 2+. If I have Fe2+, going to Fe3+, then it's going to take 1 electron to balance the charge. Does that make sense? Okay. Okay, overall redox reaction. Can you tell just from looking who the spectator ions are? without going through the complete ionic and the net ionic and all of that. Is F minus a spectator ion? Let's take a look. Let's take a look. Let's do our complete ionic equation. F2 stays as F2. We have an ionic compound, which is aqueous, so it splits apart into K plus and Cl minus. We have another ionic compound, which is aqueous, so it splits apart into K plus and F minus. And Cl2 is not ionic, so it stays together. So who are the spectator ions in here? K plus. It's the only thing that doesn't change. So now, if you wanted to split these into two half reactions, what does F2 become? F2 becomes 2F minus, and 2Cl minus becomes Cl2. Can you tell just from looking which is the oxidation and which is the reduction? Is F2 being oxidized or is F2 being reduced? It's being reduced. It goes from an oxidation number of 0 because it's an element on its own to an oxidation number of -1. Okay, so it got smaller, so that is reduction. We have chloride on the left, which has an oxidation number of -1, and chlorine on the right. What's the oxidation number of chlorine on the right? 0, because it is an element on its own, and so this is oxidation. The number got bigger. To split it apart into half reactions, we simply take the F part of it and write it separately. Okay, we need to add 2 electrons onto the left-hand side, so we have 2 negative on the right and 2 negative on the left. Same thing with chlorine, except for backwards. We need to add 2 electrons to the right-hand side so that we have 2 negative on the left and 2 negative on the right. Is good? Okay. You might be able to skip step 1 and go directly to writing the half reactions. That's totally fine. But if you're not able to see it right away, write the complete ionic and net ionic, and that will get you there. Okay? All right. That was easy peasy. We have some questions here. This is going to be for homework. We're not going to worry about that because you have to watch the video, because guess what you need to define? Oxidizing agent and reducing agent. Seriously, 10-minute video. Watch it when you get home. Okay. Balancing half reactions. This is our next skill. This is an easy skill as long as you learn it. Okay? Follow the rules. If you don't learn the rules, it's a hard skill. If you learn the rules, super easy skill. Okay? They're like free marks. But if you don't learn it, it's like throwing marks away. Don't want you. Don't want a 4 out of 4. No, thank you. Okay? So here's our rules. Balance all the elements except for hydrogen and oxygen. Okay? So we call those the major atoms. Okay, so major is everything except for H and O. Next, we balance O. And then finally, we balance hydrogen. Not finally, because finally is charge. We balance charge. Now, how do we balance oxygen? We don't put coefficients in. We don't add oxygens. What do we add? We add water molecules. Okay? So it's important that you know how to balance oxygen. Adding water. How do we balance hydrogen? Do we put coefficients in? No. Do we change subscripts? No. What do we add? H plus ions. And then finally, just like we did in the previous examples, we balance the charge by adding electrons. Now, little memory device, also known as a mnemonic device. Major hydroxide says charge. Okay, I don't know why he says that, but it's okay. Major hydroxide says charge. That means balance the major atoms first, and then balance oxygen, then balance hydrogen, and then balance the charge last. Okay, so major OH charge. This will balance your half reaction in acidic or neutral conditions. We'll talk about basic conditions later. Okay, and this is just one step along the way. Eventually, we're going to be balancing the whole redox reaction, but step one is to be able to balance the half reaction. And we're going to worry about this basic part later, so we're just going to skip over it for now. Okay? And we're going to do this example here. So remember, major OH charge. And what do we use to balance the O? Water. And what do we use to balance H? H plus. And what do we use to balance charge? Electrons. Okay, so we're going to do that. Oh, and the major ones we balance using coefficients. Do we have any major elements in this half reaction? Anything that is not oxygen or hydrogen? Yeah, we have Mn. Do we have the same number of Mn on both sides? Yes, there's just one. Oh, good. Check. That was easy. Now, do we have the same number of oxygen on both sides? No. So what we're going to do is we're going to say, now I have Mn, 3 plus. I need to now balance oxygen by adding water. How many waters do I need to add to get my 4 oxygens? 4 H2O. Okay, so now we've done our water. All right, what comes next? Hydrogen. How many hydrogens do we have? We have 8 hydrogens. And that's on the left-hand side. So what we're going to do, and eventually you don't have to write this every step out on a separate line, but I'm going to do that for now just so you can watch each step as it goes. Okay. Eight hydrogen. And then I like to do my little calculation over on the side. I have a 3 positive over here on the left because I have a 3 positive here. And what does the water have as a charge? 0. Okay? So over on the left, I have 3 positive. And on the right-hand side, I have a negative, plus I also have 8 positives. And I tend to mess up if I don't write this out. So I'm going to write that I have a -1 and I have a +8. And together, those make +7. Yes? Okay. So which side will I add electrons to? Will I add electrons to the more positive side or to the less positive side? To the more positive side, because electrons are going to make it negative. So you're going to add electrons to the more positive side. That's an R. Doesn't look like an R. Still doesn't look like an R. What is wrong with me? 4. So how many electrons do we need to add to make those equal? 4. Okay, so we're going to write our whole thing now, Mn 3 plus 4 H2O goes to MnO4 minus plus 8H plus 4 electrons. Okay? Half reactions should always have electrons in them. That's a lot of space. That's okay. All right. Half reactions always have electrons in them, and I'm going to make this note right now. Full redox reactions never have electrons in them. And that's going to be important because we're going to eventually balance full reactions. And people will try to use this technique on the overall reaction, and they'll end up with electrons in there. And then you'll be sad. Okay? Now, after we've balanced this, is this an oxidation or reduction half reaction? This is an oxidation because we have lost electrons. Okay. Is good. Let's try the next one. I2 goes to IO3 minus. Remind yourself, write down for yourself what the order is and what you use to balance each thing. So what do you balance first, second, third, fourth? Do you want to try this one on your own? You know what? You can try it. If you're like stuck, you can watch me do it like in slow-mo up here. Okay? What do you guys think of my work so far? So I started with my major atom, iodine. Yes, I had 2 on the left, so I needed to balance with the coefficient 2 on the right to give me 2 iodines. That gave me 6 oxygens. On the right-hand side, I had no oxygens on the left-hand side, so I needed to add 6 waters. Yeah? Oh, it should have a negative charge. Thank you. I spent my entire high school career dropping my negative charges, and apparently that has not changed at all. Thank you. That would have been a problem at the very end. So I will say to you, when you get to the very end, go back and check. Okay, I did eventually learn to go back and check when I was writing my test, but now I'm like old and my brain is falling apart. So yeah, thank you. All right, so that's our oxygen. Next comes hydrogen. How many hydrogens do we have? We have 12. Yes, 6 times 2 is 12. Hydrogen. So over on the right-hand side, we need to add 12 H pluses. And now we need to do our charge. What's the charge on the left? 0. And I like to put it in a little box to make it not look like an oxygen. And over on the right, we have 2 negative, and we have 12 positive. That gives me 10 positive. So I need to add 10 electrons to the right-hand side. Is good? Okay. So this is balanced in acid. Okay, is this an oxidation or reduction half reaction? Everybody, look at it quick. On the next page, there's our electrons. Oxidation or reduction? Oxidation. You should be able to do that really quickly. Okay, oxidation. I don't know why I have so much space here. What's it for? I just don't know. That's okay. Ooh, now we're going to change it to balanced in base. So let's go back and read the rules for changing it into base. So before you balance in base, you must balance in acid. So we just do acid and then we make a few changes at the end. So step 1, 2, 3, 4, keep it all the same. And now to make it basic, you do these additional 3 steps. How do you get rid of hydrogens? What can you add? You can add OH minus. So if you have 3 hydrogens, how many hydroxides will you add? 3, because you need to neutralize 3 of them. And if you add something to one side of the reaction, you need to add it to the other, otherwise it will become unbalanced. Okay? So you add the same number of hydroxide ions as hydrogen ions, and you add that to both sides. This neutralizes the hydrogen ions by producing water. Then what you do is you put together, you combine your H's and your OH's, and you make water. Okay? And then you cancel anything that needs canceling. All right, so if you've got water on one side and water on another side, and you've got 3 over here and 2 over here, you can cancel 2 of them. All right, so hydroxide, make water, cancel. Let's try those 3 steps. So we are interested in our 12 hydrogens. So how many hydroxide will we need to add to neutralize 12 hydrogens? 12. So I'm going to write underneath plus 12 OH minus. And if I was to do that and added some stuff to the left-hand side, or is that the right-hand side? Left, right? Right-hand side, it would be unbalanced, yes? So I have to also add it to the left-hand side. So I'm going to have plus 12 OH minus. So I'm keeping it balanced. Now I add it up, but when I add it up, those two become 12 what? It's no longer 12 hydrogen and 12 hydroxide. Together they make 12 H2O. And the rest of it's just copying things down. 6H2O plus I2, and then I have to put this in line with everything else, plus 12 OH minus. Is there anything that is the same on both sides of the equation? Water. Okay, we got water over here, and we have water over here. How many can we cancel? 6. So it's just like in math class. If you've got 2A on this side and 4A on that side, you're going to cancel 2 of the A's, right? So it's the same thing. So we're going to cancel these 6 water and 6 of these water. And you could just leave it like that. I'm going to rewrite it just so it's a little tidier. I2 plus 12 OH minus goes to 2 IO3 minus plus 6 H2O plus 10 electrons. And one thing you can do when you get to the end is you can check that your charge is still balanced, right? Just to make sure you haven't gone astray. If I look over here, I have 12 negatives, okay? If I look over here, I have 2 negatives plus another 10 negatives gives me 12 negatives. So my charge works. If I have more time than that, I can check all my hydrogens and oxygens and iodines. But if I just want a quick check, I can check the charge. Okay? MnO4 goes to MnO2. Do you guys think you could do the acidic part? And maybe even try the basic part? Give it a go. If you want to check your balancing in acid, I've got that up now. Red arrows pointing to it. That's balanced in acid. What is wrong with me? Is this making sense? Okay, good. Like I said, follow the rules and you'll be fine, unless you drop charges or write a number wrong, right? So if you wrote MnO3 by mistake, which people do, you know, it's just really important that you go back and check and check and check and check for silly little mistakes. Easy to make silly little mistakes. And you'll notice that I like to box my H and my OH to show that I'm making water. I do that so I don't make a mistake. You don't have to do it, but it helps to be like, oh, this is coming together to make water. Here we go. So feel free to do it if it helps you. If it doesn't help you, you don't need to. Okay? All right. There's a bunch of practice here. I'm not going to do that right now, though. We're going to move on to balancing full redox reactions because tomorrow is like a little half day, right? And if you choose not to attend on Friday, I will not be impressed with you. But, you know. Anyway, so balancing full redox reactions. Here we have two half reactions. Yes, we have a half reaction and we have a half reaction. How do you imagine that we can take two half reactions and make a whole reaction? What do you do with two halves to make a whole? You add them together, yes? So that's what we're going to do. However, we have to watch out because in this reaction, we have 3 electrons going out, and in this reaction, we only have 2 electrons that go in. And in an overall redox reaction, there are no leftover electrons. Do you remember I said no electrons in redox? No leftover electrons. So, when combining, we need to make sure, and I'm going to put a box around this, and we're going to put stars beside it. And when I mark your quiz and you get it wrong, I'm going to say electrons in equal electrons out. Okay? Electrons in have to equal electrons out. And we do that by multiplying. To get the LCM, the lowest common multiple. So we look and we say, I have 3 electrons and 2 electrons. What is my lowest common multiple of 2 and 3? 6. So I don't want to have 2 electrons. I don't want to have 3 electrons. I want to have 6 electrons. If I want to keep the thing balanced, I have to multiply everything because right now this is a balanced half reaction. And if I want it to stay balanced, I have to multiply everything in there by 2. So I need to multiply the aluminum by 2 and the aluminum 3 plus by 2 and the 3 electrons by 2. So we end up getting 2 Al, 2 Al3 plus, and then 6 electrons coming out. Same thing. If we want 6 electrons, we need to multiply by 3. So we end up with 3 times 1 is 3 copper. 3 times 2 electrons is 6 electrons. Ooh, that's the same. That's good. And then 3 times copper is, typo. That should be a 3. Fix. Okay. And now what we can do is we can add these together. And usually I like the arrows to kind of be in the same place so I can see where my reactants are and where my products are. Okay. And I can see that I have electrons on the left and I have electrons on the right. And just like in math, when you have something on the left and you have something on the right, what do? They cancel out. Boom, boom. And we are left with 2Al plus Cu2 plus. So we're basically adding these 2 half reactions together. Plus 3Cu2 plus gives us 2 aluminum, and this should be a 3. Sorry about that. 6. 3 copper. So what you're going to notice is that the numbers of atoms of each type are the same on both sides. 2 aluminum on each side. 3 copper on each side. The overall charge needs to be equal on both sides. So we have 6 positive and we have 6 positive. If you've done it correctly, it should be good. And what do you notice about this overall redox reaction? What does it not have? The redox reaction has no electrons in it. And eventually what you're going to do is you're going to take a reaction, a whole reaction, you're going to split it apart, balance each half reaction separately, and then make your electrons in equal your electrons out and add them together. Okay? That's where we're going with all of this. We're taking all of those steps and putting it all together. No electrons in the equation for a full redox. I'm going to say it 7,000 times. Okay, so rules to balance overall redox reactions. Would you guys like if I printed out a sheet with like the rules of the half reactions and the rules of the things so you don't have to flip back in this booklet all the time? I will do that for tomorrow, okay? So, rules to balance overall redox reactions. You isolate the 2 half reactions. Do you remember how we did that? We go, here's one, here's the other, okay? You balance each half reaction separately. Then you make the electrons in equal the electrons out. I'm going to put stars beside that because if people forget to do that. I'm going to put stars around isolate the half reactions too because people forget to do that. They just go right ahead and they're like redox reaction and then they start adding waters and hydrogen ions and they haven't separated it, and that's how you end up with electrons in your full reaction, okay? So you absolutely have to isolate the 2 half reactions. Make the electrons in equal the electrons out, and then add them together and cancel where necessary. You can make them basic at the half reaction stage, I usually find it easier to add them both together and then do basic rather than doing it twice with each half reaction. It's up to you though, whatever you like. And then you finally check to see that everything is balanced, and you check to see that you have no electrons. So step number 1 is isolate the half reaction. So you look and you say, who belongs with whom? Yes? Who does Mn belong with? Mn belongs with Mn, shockingly. So you just look for those major atoms, okay? So you say Mn belongs with Mn. Au belongs with Au. So we're isolating the half reactions. Okay, so we've got those two written separately. Step 2, we balance them separately. Now, I've done it here for you. You would go through all the steps that we just did, yes? So you would say, okay, I need 4 waters because I have 4 oxygens. I have 8 hydrogens, so that means I need 8 hydrogens. This is actually one we balanced earlier, okay? And I have a 3+ over here. I have an 8 and a -1, so I need 4 negatives over here, and that gives me a balanced half reaction. Gold going to gold 0 is really easy. I don't need to do much of anything, right? There's no waters, there's no hydrogens, so all I need to do is add in my 3 electrons. Okay, so we balance them separately using the steps for balancing half reactions. And then, what do you do before you add them back together? You make the electrons in equal the electrons out. So how many electrons are going in? 3. 3 electrons are going in. How many electrons are coming out? 4 electrons. What is the LCM of 3 and 4? 12. So how are we going to get 12 electrons in the first reaction here? Half reaction. Multiply by 3. Okay, so we're going to multiply everything by 3, and in the second one, we're going to multiply everything by 4. Okay, so we've got 3 and 4. And so now, when I do this, I literally, when I'm writing down this step here, I literally go through and I touch my pen to it, and I'm like, 3 times 4 is 12. 3 times 1 is 3. If I don't do that, I have a tendency to forget to multiply something by 3. 3 times 1 is 3. 3 times 8 is 24. You don't have to touch your pen. It helps me. 3 times 4 is 12 electrons. Okay? You can go through that, do the whole thing. Do the same thing with the Au, and then cancel out your electrons. Okay? And then you simply bring everything down. 12 water, 3 Mn3+, 4 Au, and the electrons canceled out. 3 MnO4, 24 H+, 4 Au. Boom! Done. So if we are balancing in acidic conditions, we are done. You can check everything. You can say, do I have the same number of hydrogens? I have 24 hydrogens. I have 24 hydrogens. I have 3 manganese. 3 manganese. 12 oxygen. 3 times 4 is 12 oxygen. 4 gold, 4 gold. Check your charge. 3 times 3 is 9 positive. 4 times 3 is 12 positive for a grand total of 21 positive. 3 times 1 is 3 negative, 24 positive, and 0 equals 21 positive. So everything is good. I cannot stress to you enough that if you check your answer and you don't get matching things, then you have done it wrong and you need to go back and figure out where you went wrong. Did you do like Miss Spence and forget to, write a negative charge? Did you, write MNO instead of MNO4? What silly little thing did you do, right? Okay, we're going to try this one now, but I'm going to do it over on the side. So if you want to get your own paper and follow along, you can, or you can watch what it says there. Okay, I don't know why I have it all filled in. I shouldn't, but there we are. What is step 1? Half reactions. So chromium becomes chromium. Xenon becomes xenon. Okay, just put the things that match together. So we write out the 2 half reactions. Cr2O7 2 minus goes to Cr3 plus. HXeO4 negative goes to HXeO6 negative. Split into half reactions, what's step 2? Balance the half reactions. Do you remember the steps for balancing half reactions? Major OH charge. Okay, so major OH charge, we balance the major one with coefficients. We balance oxygen with H2O. We balance hydrogen with H plus, and we balance charge with electrons. Okay. And I'm going to do this like all in one line. I'm not going to write out every single step in a different line this time. So major, I have 2 chromium, so I need to put 2 here. I have 7 oxygen, so I need to add 7 water to the other side. Yeah? Oh, what did I do? Oh, the 3 minus. Look at me. Wow. Thank you. Okay, that's better. There we go. All good now? Cool. Thank you. What would I do without you guys? All right. Next is hydrogen. 7 times 2 is 14, so I'm going to have 14 H plus over here. Do you see how you can do it all in one line without writing each line separately? Okay, you don't have to write each line separately. And now I need to look at my charge. I have 14 positive on the, no, 14 positive plus 2 negative gives me 12 positive, which I'm going to put in a box, so I know that's my final. And over on the right, I have 6 positive. So what do I need to add to the left-hand side? 6 electrons, okay? And I didn't leave myself enough room, so I'm throwing them in there, okay? And at this point, we should be done, okay? That's balanced in acid. Now we balance our second half reaction. Xe, there's only 1 on each side, that's easy. oxygen. I have 6 on the right and 4 on the left. How many waters do I add? 2 waters, 2 H2O. How many hydrogen on the left? 4 plus 1 is 5 hydrogen. And on the right, I have 1. And so I need to add how many to the right-hand side? 4. Okay. Charge. I only have a negative here. So that's -1. On the right-hand side, I have 4 positives and 3 negative. Thank you, because that would mess me up. 3 negative. And so that gives me 1 positive. Everybody, tell your partner, how will we get the charges to be the same on both sides? To which side do we add electrons and how many? We add electrons to the side that is more positive. How many do we need to make it equal to -1? 2. 2 electrons. Okay. And now we have balanced our 2 half reactions. What comes next? It's one of those stars. Make the electrons going in equal the electrons going out. So, do I need to multiply both? No, this time I only need to multiply this one here. So what do I need to multiply it by? 3. So I have 3 times 2 is 6 water. 3 times 1 is 3. HX, whoops. XeO4 negative goes to, oh, look, I didn't touch the 3, so I almost wrote this without a 3. 3 HXeO6 3 minus plus 3 times 4 is 12H plus 3 times 2 is 8. 6. 3 times 2 is 6 electrons. Okay. I could add them, but I like having them right beside each other when I add them. So I'm going to just quickly copy down the 14H plus Cr2O7 2 minus plus 6 electrons goes to 2Cr3 plus 7 H2O. I would recommend getting like a little highlighter or circling your electrons and making sure that the electrons in equal the electrons out. That way you're paying attention to it. Add them up. Do you see what I mean? I could have done the addition, but this is kind of hard because they're separated and I might make more mistakes. Up to you, like I said, but I like having them right beside each other because I am very error prone, as you all well know. Okay. Now, it's up to you whether you do your canceling here or whether you do it once you've added everything. Do you guys have a preference? Do it after? Okay, so we're just going to add everything. So we've got 6 H2O. 6 H2O. We have 3 HXeO4 minus, 3 HXeO4 minus plus, and these get really long. So I keep going with my reactants. I go to my second half reaction plus 14 H plus Cr2O7 2 minus. I do want to cancel my electrons so I don't have them. And now I'm gonna actually write this on the next line because I've run out of room. Okay. I have 3 HXeO6 3 minus plus 12 H plus 2 Cr 3 plus 7 H2O. Whew. Is there anything I can cancel here? I have waters on both sides, yes? So I could cancel 6 waters and get 1 water, yes? What else do I have? I also have H plus on each side. How many can I cancel? 12. So I'm going to have 2 left here, and all of those are gone. And I think we're like out of time, aren't we? Yeah. So your homework is page 21, numbers 1 to 9. No, page 21, odd. Yes? And then tomorrow we'll come back to balancing overall reactions. Okay? So page 21, odd numbers. Those are all half reactions. You should see electrons.